This is a video tutorial for tutorial 4 functions, question 1. So question 1 tells us that we've got two functions. The function f, which is defined by x mapped onto e to the x minus 1, where x is a real number, and the function g that maps x onto ln 3x, where x is a positive real number. So part 1, we need to explain why g compose f does not exist. So g compose f, what does this mean? It means that we take some input x, it goes through our first function here f, to give us f of x, and it goes through our second function then g, to give us g of f of x. So why do we write it when this is the first function and this is the second function? Why do we write g then f? It's because we put our x here. So that means that we can destroy our brackets as such. So x always goes from the right through to the left for some reason. So given that's how it works, that's how we write it. So this one only exists, what you can see here, g has a certain input and output as well. G understands certain things, it's got its own domain that it can map onto its own range. And f as well has a certain domain that it maps onto its own range. But the problem is this sequence only works when f produces something, we can then take that and put it into g. So if f makes some number that g doesn't understand, that's no good to us, right? The whole thing would break down. G wouldn't know what to do with it, and therefore we can't compose it. So does it actually happen in this case? Well, so before that means, so g on f exists, therefore, if and only if the domain, the range of f, the stuff that f produces, anything that f can produce can be interpreted by g. So the range of f has to lie within the domain of g. Well, what's the range of f? Well, if we sketch the graph, and we can do this, hold on. If we sketch the graph of y equals to f of x, which is e to the power of x minus 1, what do we see about it? Well, we see that there's no vertical asymptote, but there's a horizontal asymptote here at y equals to negative 1. So what does that mean? That means that the range of f is equal to numbers bigger than negative 1. And it can go as high as I like. So you can see obviously this is just going up and up and up and up and up. What about the domain of g? Well, the domain of g, we're told, is numbers from 0 to infinity, numbers bigger than 0. So in this case, it is not a subset. So therefore, g compose f does not exist. Part 2 says that h can be any restriction on f. So a restriction is a function with the same rule, but it can have a smaller domain. So h is any restriction on f. Find the largest domain for h such that gh is a function, and find the corresponding range of gh. So if we want gh to be a function, this happens if and only if the range of h is a subset of the domain of g. So therefore, the range of h has to be a subset of 0 to infinity, has to be entirely positive. Now, we know that h is a restriction of f, so its range has to be a restriction of the range of f. And we can see if we want it to be only positive, we need to cut out this negative segment here, right? So anything that can produce a non-positive number, that means everything up to and including the number 0. So looking at that, we restrict h to, so we want h to map x onto e to the x minus 1. We knew this already. And we want this also to be positive. For this to be positive, we need x to be strictly bigger than 0. So we need x bigger than 0. Right. So now that we know that this is our restriction, and this is the maximal domain, the largest domain, anything smaller will also work, but anything larger will not. GH is now a function. So what is the corresponding range of GH? Well, let's do this by finding out the entire... Well, okay, I mean, there's two ways of doing this. The first way of doing this is you see that the range of H is now equal to the domain of G. So because the range of H equals to the domain of G, therefore the range of GH is just going to be the range of G, which we know if looking at the function ln 3x is all real numbers. But maybe you're not convinced by that. How else could we do this if we didn't want to do it using this somewhat hand-wavy logic? Well, what we could do is we could say that we could try and calculate what is GH. So GH of x is equal to ln 3 e to the x minus 1. And we could draw this graph, and we remember we also need x to be strictly bigger than 0. So let's draw that graph. So get rid of this, just won't show that anymore. So I want to call this GH of x, and this is equal to ln 3 times e to the power of x minus 1. And sorry, I should also put a restriction on that, my bad. If x is bigger than 0. So this is how I'd put a restriction on it. And it actually didn't matter in the end. So what you can see is that this graph goes all the way from negative infinity, and you can see that it's going down there if I zoom in. It's just going to keep going lower and lower and lower. It's never actually touching the axis. So it goes all the way down to negative infinity, and you can see it's growing. It's growing linearly, but it is growing all the way to infinity. So therefore, so the graph, if we want to sketch it, would look something like this, where x equals to 0 is an asymptote, and it grows and then goes linear. So this is y equals to gh of x. So from the graph, the range of GH is equal to any real number, positive or negative. And so that brings us to the end of question 1.